So every CPU will have an adder, either it is a normal adder or a ripple carry adder or carry lookup adder. Some kind of adder will be there, and with the same adder it will even try to perform the subtraction. It is followed in almost every computer. So the same adder is going to perform subtraction as well. So how will this subtraction be done is, if you are trying to subtract like this, if you try to do a minus b, then it is going to be performed as a plus 2's complement of b. Got it? And now, since we are talking about these branch instructions, generally we have something like this: if a is greater than or equal to b, or if a is less than b, or if a is greater than b, then we generally have this type of statements in almost all the programming languages. And in order to support these high level language programs, our CPU has to provide some program control instructions which will be useful in implementing this. So one such operations are like this: branch if 0, branch if not 0, branch if greater, branch if less, like that. So the underlying concept is, it will take two operands a and b, and it will perform a minus b like this, a minus b, and it will not save the result. CPU will not save the result anywhere, but it will use the status flags to set some of the bits. Now using those status bits, we should derive which of these following conditions is true. That is all about this topic. So what I'll do is, I'll show you exactly what CPU will do whenever it is going to subtract a number from other number. Why subtraction is of more interest here? Because comparing two numbers is nothing but subtracting. Even though you write a is less than b or a is greater than b, in order to implement this, it is going to use subtraction itself. So let's see, we shall take a number and we shall see how to implement it. Assume that we have a 8-bit ALU. Let us say a equal to 10 10 111, a number like this. Or instead of taking this big number, let's cut it short. Let's take a smaller number. Let us assume that we have a 4-bit ALU, which means we will be providing the data inputs which are 4 bits, and the output will also be 4 bits. Instead of taking 8 bits, let's take 4 bits, just to keep it simple. Let us take a number like this, some number like this. And now, using an adder itself, if you try to do the subtraction, and if you write a minus b, let's see what happens here. If I try to do a minus b is nothing but 2a, I have to add 2's complement of b. For that reason, I am supposed to find out what the 2's complement of b is. So if you try to find out 2's complement of b, it is going to be 1110. This is 2's complement of b. This is a, and this is 2's complement of b. Now a minus b is nothing but 2a, we should add 2's complement of b. So a is going to be 1100, and 2's complement of b is going to be 1110. And now it will be added 0 1 1 0 1 1. This is carry, right? Now we have this program status word. Program status word is nothing but collection of all the flags which are present in your computer are going to be program status word. So in program status word, we have mainly 4 flags. That is what we are considering. In most of the computers we have more than 4 flags, but in this one we shall consider 4 flags. Okay, Z is there, B is there, S is there, C is there. Z is nothing but 0. If the result is 0, then Z flag will be 1. Since the result is not equal to 0, Z flag is equal to 0, right? And next one is V. V is nothing but overflow. So overflow, we know that V is exclusive or V is equal to C in exclusive or C out. carry in and carry out, where carry in is the carry that will come out of this phase into this one. This is carry in. Carry out is the carry that will come out of this stage, right? Now carry in this case is 1 and carry out of this phase is also 1. So when I do this, it is going to be 0. Therefore there is no overflow in this case. Whenever there is overflow, we have to handle it differently. If there is no overflow, we have to handle it differently. And coming to overflow, you please watch that 2's complement number system in digital. There I discussed about overflow clearly. And now what about sign bit? Yes, so since sign bit is nothing but the most significant bit, this one, since this is 1, sign bit equal to 1. And what about carry bit? Carry bit in this case is 1. We got a carry, right? So these are the flags which will remain after the operation a minus b. So when you apply that compare operation, which I have shown you earlier, compare a and b, when you are trying to compare a and b, the result of a minus b will not be stored anywhere, but the flags will be stored. Now depending on these flags, we are supposed to find out whether a is greater than b or a is less than b or a equal to b. But then it depends on how you interpret the numbers. So there are two ways you can interpret these numbers. Whatever way you interpret it, CPU operation is always going to be the same, but then your interpretation can be different. Either you can interpret them as signed numbers or unsigned numbers, but for a CPU both are considered as same and the same thing will happen. But if you look at them as unsigned numbers, in case of unsigned numbers, you can think of this one as, see this, in case of unsigned numbers, this one is nothing but 12 and this one is nothing but 2, right? So if you consider these two numbers as unsigned numbers, the result that should come out by looking at these 4 flags should be a is greater than b. In case if you consider these two numbers as signed numbers, then this one is going to be minus 4 and this one is going to be 2. In this case, the result that should come out is it should be a is less than b, right? In case of signed numbers, a is less than b. In case of unsigned numbers, a is greater than b. That is what you should come to as a conclusion depending on how you interpret the number, right? In case if you consider this one as signed number 10, if you are taking it as a signed number, 1010 is nothing but minus 6, which is true. Minus 4 minus 2 is minus 6. And in case if you take it as a unsigned number, 1010 is 10, right? So in case of unsigned number, the result is 10, and in case of signed number, the result is minus 6. But anyway, we are not interested in the exact result, but what we need is, by looking at these flags, we should derive that these conditions are true. So what I do is, in case of signed numbers, we verify 3 flags. First thing is, if you are talking about a signed number, there should not be any overflow first. So if overflow is 0, then if 0 flag is equal to 1, if there is no overflow and if 0 flag is equal to 1, I can declare that these two numbers are equal. Why? When I perform a subtraction, the result is 0 only when the two numbers are equal. But in this case, you can see that 0 flag is 0, which means there is no overflow and both are not equal. Then in case of signed numbers, how can you guess which one is greater? That depends on the sign of the result, right? If the sign of the result is negative, in this case the sign of the result is negative. Why? Because it is 1. Sign of the result is negative, therefore we can say that from these 3 we can derive that a is less than b. By, if you have a number a and b, if a is 2 and b is 5, if I perform a minus b, you get minus 3, which means sign of the result is negative. Whenever sign of the result is negative, we can declare that a is less than b. That is what has happened here. A is minus 4 and b is 2, because I am thinking of them as signed numbers. That is why I got this. Minus 6 is nothing but negative number, and so we can say that a is less than b. Therefore, in case of signed numbers, always remember we are going to use sign flag. This is the main factor which will decide the result. What about unsigned numbers? In unsigned numbers, we are talking about only positive numbers. We don't have negative numbers at all. Then how can we know which one is greater and which one is lesser? We should not look at this sign flag. We should look at some other thing, right? So in case of unsigned numbers, always we need not worry about the overflow. Therefore, V is useless. First, you look at the Z flag. If Z flag happens to be 1, then it means that the result is 0, which means that both are equal, right? But in this case, Z happened to be 0, which means both are not equal, right? And then the next flag we should look at is C, so carry. So actually here carry is 1. When you are talking about the subtraction, we should not be worried about the carry, but we should be worrying about borrow. But if you look at 2's complement subtraction, if you want to convert carry into borrow, it is nothing but the complement. Carry and borrow are complements. So whenever you are talking about 2's complement addition, which means if you are subtracting a number by using 2's complement addition, then the borrow is nothing but complement of the carry, which means even though here you got carry is equal to 1, it means that borrow equal to 0. Now when will borrow be not required? If you are performing A minus B, if borrow is not required, it means that definitely A is greater than B. You have to interpret it that way. Or if you didn't understand what I said, you have to remember these conditions, right? So in case of signed numbers, if I perform a subtraction, this condition indicates A is less than B. This condition indicates A is greater than B in case of unsigned numbers. Got it? So depending on how you interpret these numbers, you have to use the corresponding flags. If you are interpreting the numbers as signed numbers, you have to use these 3 flags to declare the answer. In case if you are interpreting them as unsigned numbers, you have to use these 2 flags. Got it? So whatever it is, what I mean to say is, once you decide about how you are going to use these numbers, you are going to apply this. Got it? Now let's take another example and again see the same thing. Let us take the same numbers but in a reverse way. Assume that A equal to 0 0 1 0, B equal to 1 1 0 0. In case of unsigned numbers, this one is 2 and this one is 12. In case of signed numbers, this one is 2 and this one is minus 4, right? Now let's perform A minus B. As usually, not to perform A minus B, you are supposed to find out 2's complement of B. Now 2's complement of B is nothing but 0 1 0 0. That is 2's complement of B here. Got it? And now A minus B is nothing but A plus 2's complement of B. A is equal to 0 0 1 0 and 2's complement of B is nothing but 0 1 0 0. Now you add these two. I get 0 here, 1 here, 1 here, 0 here, right? Now let's see what is program status word. So we know that program status word has got 4 bits. So what are they? Z, V, S, C. Is the result 0? No. Therefore Z equal to 0. It means that A is not equal to B in any of the cases. Either it is signed number or unsigned number. In both the cases it is true. And what about V? V is nothing but overflow. So what about overflow? We know that V is exclusive OR of C in and C out. So in this case, C in is 0, isn't it? There is nothing going into it. And C out is 0. There is nothing coming out of it. Therefore 0 exclusive OR 0 is 0. So 0 here. And what about S? Sign flag, right? So sign flag is nothing but this one, the most significant bit, which is 0. And what about C? Carry. There is no carry, therefore it is also 0, right? Everything is 0. Okay. And now you are supposed to derive the conditions. So first let's assume that it is a signed number and see what has happened. See this? See, depending on these conditions we should declare, but then since it is an example, I am just showing you how it is done by taking the numbers itself. In case of signed numbers, what is the result? 2 minus of minus 4 is 6. Which one is greater? 2 is greater, right? And in case of signed numbers, 2 minus 10 is 2 minus 12 is minus 10. Isn't it? Actually you have to take 2's complement of this, then you will get minus 10. Okay, but anyway, what I mean to say is, in case of this unsigned numbers, you are supposed to get a is less than b, and in case of signed numbers, you are supposed to get a is greater than b. Now let's see this signed case. In case of signed case, you are supposed to look at 3 flags. What are they? V should be 0. Yes, V should always be 0, otherwise we cannot work. And then Z. What about 0 flag? Z should be 0. In case if Z happens to be 1, we can directly declare that A is equal to B. Now here Z is 1, and the next one is sign. So why am I considering this sign bit? Because since it is a signed number, the sign of the result will say which one is greater, right? In this case, sign happened to be positive. So observe this, we have performed A minus B, and now we got the result as positive. Therefore definitely A must be greater than B, otherwise we don't get the result as positive. Got it? And in case of unsigned numbers, again we have to test two flags, right? V is not useful there, we have to test 0 flag. So see this 0 flag. So in this case, 0 flag happened to be 0, which means both are not equal. In case both are equal, we get the result as 0, and 0 flag will be 1. And the other one is carry. So in case of subtraction, if you are looking at carry, we should think of it as borrow, but a complement of it, right? So here carry is equal to 0. What does it mean? Borrow equal to 1. Now in subtraction, when do we need borrow? We need a borrow if A is less than B. Therefore in case of unsigned numbers, A is less than B. Got it? So this is how you should interpret it. Okay, so if you want to summarize it, what we are trying to do here, I'll just put everything together and you can remember the final one. So when you are having these flags, if you are trying to do this comparison, which is nothing but subtraction followed by testing the flags, we are not going to use the result at all. So when you use this compare instruction, it will just subtract and it will not store, the CPU will not store the result, but just by looking at the flags, we are supposed to derive what the conditions are. Okay, now there are two cases. Either you interpret as signed number or you interpret it as unsigned number. In case if you interpret it as signed number, we are supposed to look at 3 flags. What are they? Overflow flag should be looked first, and after that 0 flag should be looked at, and after that sign flag should be looked at, right? Now how do you look at overflow flag? If overflow flag is 1, which means if there is overflow, then we cannot declare anything, right? Which means this is invalid. Alright, if there is overflow, we cannot decide whether A is greater than B or A is less than B, because the result of subtraction happened to be a number which does not fall in the range, right? In case if there is no overflow, in most of the cases, the numbers will always be given in such a way that the arithmetic operation will not overflow. In case if there is no overflow, if the result happens to be 0, then also we need not look at this sign bit. We can directly declare that A is equal to B, right? Both are equal, we can declare that way. In case if 0, overflow is 0 and 0 flag is also 0, what does it mean? The result is not equal. I mean A and B are not equal and there is no overflow. If the result is a positive number, see, we are performing A minus B and the result happened to be positive number, then what can you say? Definitely A is greater than B, isn't it? In this case A is greater than B. If you get 0, 0, 1, there is no overflow and the result is not 0, but then the result is a negative number. If you perform A minus B, when will you get a negative number? Only when A is less than B, isn't it? In this case A is less than B. So in case of signed number interpretation, if you think of these numbers as signed numbers, okay, and if you are trying to perform a comparison, then a subtraction will be performed, and then based on the flags we can declare what is the relationship between these two numbers. Got it? So similarly, in case of unsigned numbers also you can do this comparison, but then we don't need overflow, because in overflow will happen only in signed numbers, but in unsigned numbers overflow will not happen, right? So we are going to look at these two flags only. In case if 0 flag is 1, you need not worry about carry, you can directly declare that A is equal to B. In case if they are not equal, then there will be no 0 result. In that case, there are two ways. One is there is a carry, there is no carry. If there is no carry, then it means that there is borrow, right? Carry and borrow are complement of each other when you are talking about 2's complement subtraction. If you are performing the subtraction using 2's complement addition, then there will be borrow if there is no carry, and there will be no carry, and if there will be no borrow if there is a carry, which means carry and borrow should be taken as complement of each other. It says that there is a borrow. When will there be borrow? There will be borrow if A is less than B, isn't it? Check that. C is 0, then it is the case. Now the other one is, here we have 0 and here we have 1. What does it mean? There is no borrow. There is no borrow means A is bigger than B. A is greater than B, right? Therefore, using these flags, we can directly compare A and B. So whenever you write if A is greater than B or A less than B like conditions in your program, then ultimately both of them have to be compared, and then these flags have to be tested. Now which flags will be tested, that depends on whether you declared the number as an unsigned integer or a normal integer. In case if you declare it as a normal integer, it means that it is a signed number. In case if you declare it as a character or a unsigned integer, then these flags will be used. Got it? So anyway, we have the facility to implement these program control statements using these branches which are conditional. Now we shall see what are the various types of conditions or branches we can use by looking at these flags. We shall see a list of it. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.